So everybody should have their RStudio open. Is it for everyone? You start your RStudio. If you're on your quiz page, this is your instructions. That's on the top of the quiz, on top of the sample test. It gives you instructions to prepare for the test. There's a link for the sample data file, sample test1.r. You have to download that file. After you do that, we'll go through the procedure of importing it into RStudio. As we have said earlier, all of your code has to be written in the R script file. You should not write your code in the console and then copy the code and the output in the R script. Okay. You're allowed one page of notes and the R resource pages, and you can use R itself and use the help file in R. I will show you how to use the R help if you don't already know it. One important thing on the test is how you put your decimals. As you've seen in your tests, that rounding off errors give you wrong answers. So keep a lookout for the instructions on up to what decimal places the answer is expected. All of your percentages are to be written in proportions or in decimals. So if it's 70%, you write it as 0.7. If it's 18.92, then you write it as 0.1892. So I'm guessing everybody has downloaded this data file. In your RStudio, just go to open file icon here. It should say open an existing file, or you can press Ctrl+O. Then go to your downloads folder, open the sample test1.r. Import it, give your confirmation, and then you will have all the data here in your environment variables. You should be able to see all this data here. If you have a bunch of stuff typed in your console from your previous R scripts and you want to clear that, you just press Ctrl and L and it will clear your console. Yeah. I don't really know about how to get the other attempt, but I'll talk to the professors and I'll let you know. I'll talk to the professors and I'll let you know. Just send me and the professors a mail and we'll get back to you. So this is your practice test. You downloaded the data file. It's in your environment variables. If you want to see, you just click on any of the data, it will open it. And now we are set for the test. the first question is your seat number. That's okay. And the second question is where your test actually starts. A financial analyst downloads a data set with 2-year percentage returns of the Standard & Poor's 500 index. The data is in the file daily returns of 2015 and 16. This data would be considered, check all of that apply. So the options are cross-sectional, categorical, quantitative, and time series. So can someone tell me an example of a cross-sectional data? Or a categorical, or quantitative? What do you think would the answer would be in this? Okay, time series. Any other answers? What? Any other answers? Okay, why? Yeah, and it is a time series because it's over a time period and the data is numerical, so quantitative. So that would be your two answers. It's quantitative and time series. Quantitative because it's numerical data, and time series because it's over a time period. Okay, does anybody have any doubts in that? Yeah?
Can you explain what cross-sectional is again then?
Cross-sectional is data where you have data in a tabular form and it's in cross-section. It's not only quantitative, it can be quantitative and categorical too. Yeah.
So it's impossible for something to be time series and cross-sectional.
Yeah, it could. Yes. Time series is over a time period. So if you observe any data over a particular time, say Monday, Tuesday, Wednesday, Thursday, Friday, January 2011, February 2011. So that particular data set, you can have whatever data you want. It could be categorical, quantitative, but that is over that particular time period. So any data in that form is a time period data. Okay. So if anybody doesn't have any doubts, I'll move to the next question. So question 3, you have a data set that lists various information about all Austrian residents. Which of the following is or are categorical? So I need answers. Come on, one by one.
So zip code.
Zip code, okay. Okay. Age, income, all of it? Seriously? So which one is not? Income, okay. So does everybody get this or do you have doubts? age varies. It could be categorical if you are giving it in a category like 18 to 22, 22 to 50. So it could be used as a categorical or a numerical. It depends on how you're using it.
Like, can you say that louder? So, like, what you just said.
Okay, so age is a categorical variable when you put it in age groups. For example, under 18, 18 to 24, 24 to 30, 50 onwards, then that becomes categories.
So what's the answer?
You can also have age as a categorical variable.
Even though it can be categorical for this question, would you keep age as quantitative or would it be either or?
Generally, in most of our uses, it's a categorical variable. Yeah.
So income can't be equal. So say if you're like dividing the residence up by if they earn between something and something, is that then become a category?
You could make that a category.
And it become categorical then?
But in general, income of this is individuals, right? So now we're on the fourth question.
So the axes are labeled here and the y-axis does begin at 0, so 2 goes.
Yep. You may not be able to read this off the projector because of the display resolution, but it should be showing clearly on your desktops or laptops. So what do you think the correct answer is? Right. So the axes are labeled properly. The y-axis begins at 0, and in a bar chart it doesn't matter if the bars are touching or not. So there is nothing wrong with the graph. Let's go to the next question. Okay. So grade school girls and boys were surveyed to choose their favorite subject. The results are given in favorite subjects data, the data file that we imported. What proportion of boys said that English is their favorite subject? So I want all of you to solve this in RStudio. So here we have the favorite subjects data set. You can click on it, see the data is subject, English, science, maths, the gender boy or girl, categorical variables. To make sense out of this data, we need to get it in numbers or the counts. And for that, we use a table function. So in your RStudio, just write table, favorite subjects, subject versus favorite subjects, gender. And you run it. In your console, you should get the data that you need.
Can we just do, is it possible to just do table and then parentheses favorite subjects? To get the same table?
Yeah.
You didn't put both columns. So gender and sex.
If you just use favorite subjects, it'll give you this data. Or if you want,
Because you're telling me I want gender on one. So just
you can do it this way. By default, it gives you the first column against second column. If you want to specify, you can specify gender as the rows and subject as the column, and then you'll get this table. Yeah.
What was the command that added up the rows and columns?
We'll get there. We'll get there.
You can do this one as one.
So you want to add all of them together? All the data?
These two are the same. For the proportions, you need to do prep table. Like this table inside there.
Here it's pretty simple, so you just need to use R as a calculator. Just so boys who like English is 30. Oops. So it's 30 divided by so this is your answer. It's 0.1818. So that's 18.18%.
Could you do the prop table?
You could do the prop table.
I just got a different number.
Yeah, just a second. Yeah.
How many decimals do we have to write on the box?
How many?
Yeah. How many decimals do we have to write on the box?
That is given in the test. Ideally, it should be around 2 or 3. Whatever specific is given in the test. Yeah. So in MyStatLab, how in some answers you have to give 0.1 decimal or 0.2 decimal. So similarly in the test will be given. Okay. So here if you do a prop.table, it will give you a wrong information because prop.table gives the proportion of each element over the sum total of the entire table. If you do a prop.table here, so it will give you the proportion of each item against the entire table. But the data that we need is what proportion of boys said that English is their favorite subject. So it's boys who like English over boys in general. So that's why you can't do a prop dot table. Yeah.
Couldn't you just do prop dot table and then have an argument rows and columns right next to that? So like prop dot table comma 1.
Yeah.
You
can
could
do
do
that.
that.
A problem table comma one.
I think it's more intuitive to do it the other way than to just think about the numbers.
Yeah.
I did prop dot table and it's 0.0 and 9 5.
Yeah.
Yes. Yes. Because when you do prop dot table, it divides the each item by the sum total of the entire table. So unless you do a column or a row operation in this, you won't get the correct answer.
So what would your clause be if you were to do a prop table? Oh, okay. Comma 2.
Yes.
And what does the 2 indicate again?
Column.
So it's easier to do it with just the numbers, not the prop table,
So you use either
or
one or
just whatever.
You could do whatever you want.
Yes, whichever's easiest for us.
I mean, that depends how much time it takes you to type those numbers and how much time it takes you to type prop dot table. I think it should be around the same.
Okay.
you can always tell by like
Generally, we use prop dot table when we have large data sets and big tables so that you don't have to calculate the sum total of 10 numbers together. Here it was just 3 numbers, so it was easy and we could do it using R as a calculator. So, since everybody is clear with question 5, we'll go to question 6 now. Okay. So the US Census Bureau reported the following data about poverty in 4 regions of the United States in 2013. A total of 312,966 households were included in the study. What proportion of individuals in the study live in the South and below the poverty level? Yeah.
Can you go back to number 5? Because I can't see the R squared
Okay.
here. Pull it up. So if you have, like, what is that? What do you, on line 5, what does that say?
On line 5,
Yeah.
that's just 30 divided by the sum total of 30 plus 65 plus 70.
zoom in.
Oh no, it's not there, right? If you see the console, you can see boys who like English 30 divided by boys in general, so that's 30 plus 65 plus 70. So now on question 6, we have to find the proportion of individuals in the study who live in the South and below the poverty level. So what is the number of people that fit this criteria? Anybody? So people who live in the south and below the poverty level. Okay. So that would be 18,870 people who live in south and who are below poverty. So to find out the answer, you just have to divide 18,870 by the sum total respondents. That is 312,966. So what's the answer? 6.0? Okay, 6.026. So that's 6.03. But in this test, you had to write all proportions in decimals. So you can't write 6.026%. You just have to write a 0.06.
Yeah, 0.06.
Yes.
So the two tells add, make the columns equal. If you change it to a 1, change it to a 1, see what it does.
So for question 7, we can see a mosaic plot. And the one that is here shows the relative proportions of business in this data set as groups by nations and industry. So which of the following best explains why a mosaic plot does not violate the area principle? Jocelyn? Take it for now.
Okay. So have you answered number 7?
No. They're just checking it out. Then we answer.
Okay, y'all. Mosaic plots are often preferred to segmented or stacked bar charts because they do not violate the area principle. The one below shows the relative proportions of business in the data set as grouped by nations and industry. Which of the following best explains why a mosaic plot does not violate the area principle? Okay. What do y'all think? Yeah.
So each rectangle is proportional to the number of pieces.
Okay.
Okay, anything else?
Does anyone have a different opinion? Okay. Good. Does anyone not understand any other answer choices? Yay. Okay. Data from the International Tank Owners Pollution Federation Limited displayed below give the cause of spillage for 459 large oil tanker incidents from 1970 to 2014. What is the proportion of spills caused by something other than collisions? Okay. So, what do y'all think is the easiest way to do this? Subtract, So what would we subtract?
136 times 459, and then divide that by, subtract that from 1.
So yes, we will do 136 divided by 459 and do 1 minus that answer to find the proportion of something other than collisions. So we're going to do 136 divided by 459. But we're going to do 1 minus that answer to find the percentage of stuff other than collisions. And the answer is 70.7%. 0.37%. But our test asks for just the proportion, so we're going to say 0.704. Does anyone have questions on that? Good. Okay, which of the following are illustrated in a box plot? So, what function gives you the numbers in a box plot? 5 num, good. And what is the first number in 5 num? Min,
Min.
And then what's the next one? Q1, or lower quartile. And then what is the middle number? Median, not mean. What's the fourth number? Upper quartile, and then max, So the mean is not illustrated in a box plot, just the median. Okay. So we're gonna go back to that daily returns data set. The 2-year percentage returns of S&P's 500 index are in daily returns of 2015 and 2016. Which of the following statements is correct? So we're looking at the average daily returns, and we're also looking at how spread out they are. So what function are we gonna use to see the average? Mean, And what do y'all think for seeing how spread out they are? Standard deviation, So we need to find the mean of 2015 and 2016 and the standard deviation of 2015 and 2016. So, mean of daily returns 2015, and then we'll find the mean of daily returns 2016. So we can see which one is higher, 2015 or 2016. 2016, And then let's look at the standard deviations to see how spread out they are. (2016). Okay, and then which one is more spread out? 2015 or 2016? 2015 is more spread out because it has a higher standard deviation. So we know that 2016 has a higher average and 2015 is more spread out. So when we go back to our question, we know that, I just forgot. Which one is it, y'all? 2016 is higher, and they were less spread out. Good. Any questions about that? He'll get to you. Okay. A sample of 198 house prices were obtained in a rural community. Which of the following would provide a measure of variation? So, how did we just measure variation in the last question? Standard deviation, right? Can any of these other things measure variation? What do y'all think? Does range measure variation? No one knows if it measures variation?
What's the definition of variation?
Variation, I think about it as how spread out the data is. So does range measure how spread out the data is? Yes, How about a 5-number summary? Yeah. How about median? No, How about IQR? Yes, So all of those things measure variation except for median. Okay. The mean weight of a Galapagos penguin is 5 pounds with a variance of 0.25 pounds squared. What is the standard deviation of the weight of a Galapagos penguin? So how do we find standard deviation if we know variance? Just take the square root, So we'll do the square root of 0.25, and we can use R as our calculator. And it tells us it's 0.5. Okay, so how do we know if it's 0.5 pounds squared or 0.5 pounds?
0.5 pounds because
We just square rooted the variance, which was pounds squared, so we also need to square root our units. So be careful about your units on this test because a lot of people would accidentally pick 0.5 pounds squared instead of 0.5 pounds.
So in this question, why do you think it's only positive, and why does the standard deviation why is it not negative? Because the square root of a number is positive and negative, right?
Just you took the square before, so that was canceling out the signs, making it all positive.
Not really.
Standard deviation doesn't have a positive or negative.
Yes.
It's not taken into account.
Yes.
Can standard deviation be negative?
Variance.
Neither standard deviation or variance can be negative.
Variance is always the square, so it can't be negative. Standard deviation depends on which direction you are. Away from the mean, on the positive side or on the negative side.
Okay, they have some questions back there.
Yeah, I will.
A sample of 198 home prices that house prices data from a rural community shows that the distribution is, so you want to see if it's skewed to the left, symmetric, skewed to the right, or bimodal. How would we do that in our, yes, make a histogram. So we're going to make a histogram of house prices. So we're using our hist function of house prices and of price. So when I run that, we see that there's our histogram. So our answer choices are skewed to the left, skewed to the right, symmetric with 2 high outliers, or bimodal. So is this unimodal or bimodal? Unimodal, so we can eliminate bimodal right away. Is it skewed to the left or skewed to the right? Or do y'all not know? So it looks like there's more data to the right than to the left. So now you're down to, is it skewed to the right or is it symmetric with 2 high outliers? So who has an argument for either one of those? It's symmetric with 2 high outliers. Why?
Well, if it's skewed to the right, I feel like there needs to be more of a...
It needs to be continuous, a continuous tail. Because there's that big gap, that's why it's symmetric with 2 high outliers. It's not skewed to the right because there's no continuous tail. Okay? Symmetric with 2 high outliers. Okay, the mean weight of a wombat is 60 pounds with a standard deviation of 8 pounds. The zoo has a wombat named Cooper. Cooper's weight has a z-score equal to -2. Select the best interpretation below. So what does z-score mean?
It's pretty much standard deviation.
Number of standard deviations.
The number of standard deviations from the mean. Good. So if he has a z-score equal to -2, he is 2 standard deviations below the mean. So it told us 1 standard deviation was 8 pounds. So 2 standard deviations is going to be 16. And he's -2, so he's 16 pounds below the mean. and the mean is average. So he's 16 pounds below average. So one of these answer choices, it says, this makes no sense because z-scores can only be between -1 and +1. So is that true? What is the number that can be between -1 and +1? It's R. It's the correlation coefficient, which you'll learn about later. So in the next chapter. But standard z-score can be anything. Any negative number, any positive number. Okay. How many questions are in this? 20. The admissions data file contains information about an applicant's gender, program applied to, and decision. Based on the data, is the decision independent of the program applied to? So, what is the difference between independent and dependent? They're having fun out there. Okay. Independent means that if our x variable changes, our y variable isn't going to change. Like the proportion is going to stay the same. So in context of this, it means if I applied to a different program, is my chance of getting in going to be the same? So is your chance of getting into Macomb the same as your chance of getting into engineering or liberal arts or something like that? So how are we going to do that? How do you think we should check that? You can do prop table.
Okay. But do you do a prop table directly on the data set? Okay, fine. So what do you do before that? Yeah. So the data set has categorical variables. You have to change that into numerical. That's what you do using a table function.
So we have to do prop.table of a table. So first we'll make our table of admissions decisions. And then I want program and I want decision to see if the program has an effect on decision. So we could do a prop.table now. So I'll call it table 1 and I assign the variable name. So now that's called table 1. And now I'm going to do a prop.table of table 1. Do I need an argument in my prop.table? Do I want the proportions of the whole thing, or do I want them of the rows, or do I want them of the columns? What do y'all think? So we want the proportions of the students that were admitted and denied for engineering and admitted and denied for English. So I want them of the rows, so I want the number 1 argument, and that showed me 50% were admitted to engineering and 50% were denied to engineering, and then it said 25% were admitted to English, 75% were denied to English. So okay,
where do you think is a better chance to get selected?
Engineering, good. So, back to the question, is the admission decision independent of the program applied to? So, if it was independent, it would be the same proportions for both English and for engineering. Because those proportions are different, the program you apply to has an effect on the likelihood of your decision. So they are dependent, they're not independent, because we weren't even dealing with gender in this question, so it's obviously not the first answer. And then it's no, because percentage admitted is different for English and engineering. And we did that with a table and a prop.table.
Can we go back to the R script?
Yes. So we did a table of program and decision. We did a prop.table of that table. And we wanted the row percentages. So that's why we did comma 1. If you wanted the column percentages, it would be a comma 2. If you wanted the percentage out of the whole thing, you wouldn't have a 1 or a 2. You'd have nothing.
Comma 2 is what?
Comma 2 is for column. So the column proportions will add up to 1. He'll get to you in a second. Yeah. Prop.table is proportion table. Okay. House prices includes a sample of 198 home prices from a rural community. Find the standardized value for the home with the highest price. So we need to find the house with the highest price, and then we need to standardize it. So first, how do we find the house with the highest price? What are you going to do? What do y'all think? Just a max? So we're going to find a max of house prices and that price. So we just found that the max house price is 327.2. Okay, so once we found that max house price, now we need to standardize it. So to standardize something, we need to do what? How do we standardize something? So you do your value minus the mean divided by your standard deviation.
And you get your z-score.
That's standardizing means to find the z-score. So we need to find the mean.
Do you know why we standardize? Or why do we find the z-score? Yeah?
Different data sets with different units, it makes it possible to compare across.
Right.
Perfect, yep.
Yeah. So we scale them down to 0 mean and 1 standard deviation. And that's how we can compare two distributions. 0 mean.
Mean is 0.
Mean is 0, standard deviation is 1.
So I did my max function, I did the mean function, and I did the standard deviation function. And now I'm going to do my max minus mean divided by standard deviation to transform it into the mean 0, standard deviation 1, z-score. So our max is 327.2 minus 150.4056. And I'll put that in parentheses. And then we're going to divide by the standard deviation. And we run that, and we find that the z-score is 6.81, or 8097, which rounds to 6.8081. Okay. Yeah. So we found our value, we found the mean, we found the standard deviation. Then we did value minus mean divided by standard deviation. That's something that you should definitely write on your cheat sheet. Okay. What?
What does the last thing on the R script say? Like the numbers. So 327.2.
327.2 minus 150 divided by 25.
Minus 150 divided by
The standard deviation. $25.962. So I just copy and paste it from the console back into my script to put the numbers back in. Okay, number 17. What differentiates a histogram from a bar chart? Choose all that apply. So what What kind of data goes in a histogram? Quantitative, good. So, the first one's definitely not right. Okay. The second one, histograms have numbers on the x-axis while bar charts have categories. Is that right or is that wrong? Huh?
That's right.
Yeah, that's right. So our histograms are for quantitative data, so they have numbers on the x-axis. Bar charts are for categorical data, so they have categories on the x-axis. Okay, histograms only have percentages on the y-axis, while bar charts only have probabilities on the y-axis. Is that right? Do histograms have to have percentages on the y-axis? What kind of histogram has percentages on the y-axis? Relative frequency histogram, good. So a regular histogram will just have counts on the y-axis, so it's not the third answer. Both histograms and bar charts should have gaps between the bars. Is that true?
No.
Which one should have gaps? Bar charts, good. Okay. Number 18. A survey for eye color with gender yields the following results found in results and summarized below. The marginal distribution for eye color is, so the marginal distribution for eye color, are we finding column or row percentages? Column, So, what functions would we use to do this? So, let's open our results. So, what do we have to do first? Because this isn't numbers. We have to make a table of results. And we want it of gender, and we want it of results of eye color. And when we run that table, it shows the table like it did in the question. And then we want our proportions, so we use prop.table. So let me go back and name that table.
Do you have to name it or?
You could do prop.table and then put that other code inside your prop.table. You can do it either way. So then we're gonna do prop.table. Ooh, prop.table of table 1. And when I run that, that does the proportions for all of them. I don't want it for all of them. What do I want it for? Columns. So do I put 1 or 2? 2. When I run that, oh, I think you're supposed to add them together. Yes, you're right. I've actually never used margin.table because in my mind it's easier to do it by hand. Margin.table. Okay, so is margin.table supposed to have a parameter, an argument? Ooh, y'all. So, okay, so what that just did, so when I did margin.table of the whole thing, that did the whole total. So everything together is 175. And then this margin.table, one of the columns, added the columns together. So all the black eyes is 20 plus 25 is 45. So you can do 45 divided by 175, 30 divided by 175, 45 divided by 175, and find all those percentages. Or I think we can do this, divided by margin.table of table 1. And then that will give you the percentages. So what I just did was our margin.table of when I have the 2 parameter gives me the totals for all of the columns. And I want the total for all of the columns divided by the total for the whole table. So that's why I did that margin.table of the columns divided by the whole total. And that gave me those percentages. If that does not make sense to you, don't try and do it in R code. Just do it using R as a calculator. You will get the right answer, and it might be faster for you. You have a question?
Is your R script being created on like doing that?
No. Just get the right answer. This class is not about learning R. This class is about learning statistics. So you don't have to use these functions. Okay, so which is the right answer? The first one. Good. Okay, consider the following data found in data. The 5-number summary for this data is, how would we do that? 5num, good. That's an easy one. Okay, when I do 5num, tells me those numbers. What's the first number? Min. What's the second number? Q1. What's the middle number? The middle number in 5num? Median. The fourth number is Q3. And the last number is max. So when I go back to this, which ones can we eliminate right away because they don't even have the right titles? The second one and the third one, good. So which one is it, the first one or the second one? The first one. I'm taking your word for it because I don't remember the numbers. So that one, you just use the 5num summary and know that it's min, Q1, median, Q3, and max in that. And your last question is save your R script as your UTEID and upload it to question 20. If you have any questions about how to save your R script and upload it, I will show that right now, but you should probably know how to do that. We do file, save as, and I'll save it as my UTEID, save it wherever you want it, and then upload it to that Canvas question. Do y'all have any other questions?
Why did you do data $sign data?
I don't know if you have to do that, but I just do it as habit.
What is it?
It tells R to go to the table called data and pick the data from the column called data.
Mine doesn't work like that. You have to do the NA.
I would ask him because I'm not at your computer. Number 16. Okay, number 16.
It means find the z-score when it says find the standardized.
So, okay, when we standardize a value, we're doing the value minus the mean divided by the standard deviation. And it said standardize the home with the highest price. So what I did was found the home with the highest price by doing max and then subtract the mean for that data and divide by the standard deviation. So yeah, I found the max value and then I found the mean and then I found the standard deviation. I'll pull this up. The home with the highest price. Well, okay, so I used max to find what the house with the highest price is. So there we go. So so the highest priced home is max of price. So that's our value that we're trying to standardize. then you subtract the mean and divide by the standard. Make your cheat sheets over the weekend. If y'all have any other questions, email the TAs and your professor. Just CC all of us if you send an email, so whoever gets to it will send you the email back the fastest.
Oh, do we need to bring our own laptop to the test? Or
No, you will be forced to use these computers.
okay.
You're forced to use them, so
On
don't
the
worry about
cheat
bringing your
sheet,
laptop.
we can write anything on it.
You can
Is it
write
front and
anything
back?
on it, front and back, one standard piece of paper.
Okay. And then my other question is on the engineering English question. You're saying which one was like harder to get into?
So you're saying, so the way, okay, so like, is your chance of getting into McCombs, your chance of getting into liberal arts school, is that the same?
Okay.
So is the program you're going into, does that have an effect on the percent that you're,
Okay.
the likelihood that
So
you're
in the
going
case
to
of this one, it was like engineering.
So 50% where people were admitted